Before Alison tackles the final equation, let's look again at the two general rules she's been using. Most importantly, remember that an equation is like a set of scales, so that you can do almost anything you like to an equation, provided you do the same thing to the other side, to keep the balance. The second rule helps you decide what it is that you should do to both sides of the equation. So to undo an operation, you should do the opposite. To undo a subtraction, you add. To undo a multiplication, you divide. To undo a square root, you square, and so on. The final equation can be rearranged using exactly the same principles, remembering to keep going in a series of small steps. It's like peeling away layers of an onion, but it needn't end in tears.
So, this is your last equation. Looks a bit horrible. The delta, like before, is a change in something. So, right. Delta EK is a change in the kinetic energy of an object of mass m that increases its speed from u to v.
Okay.
And what I'd like you to find is an equation for u. You are?
Okay.
We won't go for the u's straight away. We'll go for this whole term here.
Okay.
And let's try and at least get that on the left-hand side.
Yeah.
So what would you have to do to get that onto the left-hand side?
Well, it's subtracted here. So
yeah.
If I add half mu squared to both sides.
Yes.
I'll just... So if I do delta EK, add a half mu squared, that is equal to a half v squared minus a half mu squared plus a half u squared.
That's fine. So you've added that to both sides, so you've preserved the balance again. So what can you cancel?
Those two cancel each other out.
They do.
So I'm left with...
That's fine. You're left with...
delta EK plus half mu squared is equal to half mv squared.
Right. So now you've got half mu squared where you want it, but you've still got it added to delta EK. So what can you do next?
Subtract that from both sides.
Yes.
So delta EK plus a half mu squared minus delta EK is equal to a half v squared minus delta EK.
Yes.
And these two terms cancel each other out.
EK minus EK is 0.
Yeah, so that leaves me with a half u squared is equal to a half v squared minus delta EK.
Good, okay, so now we're really making progress.
Yeah.
Because you've only got one term on the left, at least.
Yeah, yeah.
But you've still got half and you've got m in it.
Yeah.
So what could you do next?
Well, half mu squared is the same as mu squared over 2 divided by 2. So if I multiplied both sides by 2...
Yes.
So I'll just write this out. If I've got mu squared over 2...
Right, that's exactly equivalent to that.
Yes, yeah. So if I multiply that by 2...
Yes.
Then I have to multiply the whole of this side by 2. So that's everything.
Indeed. Very good.
So I'm going to get some more paper.
Yeah, I think you need another sheet.
Oh, it goes on. So
now we're nearly there.
I can cancel these two, because I'm dividing by 2 and multiplying
Yes.
by 2. So I've got mu squared is equal to, and I have to multiply each term in the bracket
Indeed.
by 2. So that's the same as mv squared over 2 multiplied by 2. So that just gives me mv squared
Yes.
minus 2 times delta ek.
Great. Yes.
But
You've still got an
I've
M.
still got an m. So I just need to divide both sides by m. And that's
Yes.
the whole of that side by m.
Yes.
And those m's cancel, and I've still got a u squared.
That's all right. We're hoving in on it. You just got to get rid of the square.
Squared, yeah.
And what's the opposite of squaring?
Taking the square root.
Yes. So
If I take the square root of u squared, I'm left with u, and that is equal to mv squared minus 2 delta ek over m, and that's
you have to take the square root of the
whole
thing. You've done it. Well done. And actually particularly well done, because that is more difficult than anything you'd be asked to rearrange in the course. But just by going at it step by step, it wasn't actually that bad, was it?
No, just got to break it down.
Yeah.
Okay.
Excellent.
Thank you.
As Sheila said, the final equation is harder than anything you'll be asked to rearrange in S104. Rearranging equations is all about taking things slowly and steadily, undoing operations by doing the opposite, and remembering that whatever you do mathematically to one side of an equation, you must also do to the other side. Using the same rules, you should now be able to deal with any equation that you have to rearrange in S104, and plenty that are more difficult. It really is that simple.